Okay? So let me review this all together. Here we go. Let's put this all together before we do our final effect, which will not take nearly as much time. So here we go. Here we go. If somebody runs past you at some speed, then from your point of view, watching them run past, because they're moving a different speed than you, you will see their length shrink and their time slow down. Okay? But from their point of view, you're the one that's going a different speed. So from the runner's point of view, they will see your length shrink and your time slow down. So we both see the same effect happen to each other. And before I move finally to the last effect of special relativity, which again is not going to take nearly as long to explain, these two things right here are the reason that you can't go faster than the speed of light. Check this out. Here we go. Let's do this. If you were to watch something go by faster and faster and faster and faster, every time it ran by, it was faster, what would keep happening to its length every time it went by? If it went by faster and faster and faster and faster, what would keep happening to its length? Every time it went by, it would be shorter. Now, here's the thing. Could its length keep getting shorter forever? No. If we keep letting its length get shorter and shorter and shorter, what will its length eventually be? As it gets faster, it keeps getting shorter. If it keeps getting shorter, what will its length eventually be? 0. So it turns out there is a speed that once you get that fast, your length has shrunk as much as it can. Anybody want to take a guess what that speed is? The speed you go where your length has shrunk to nothing? Reduced past the size of atoms. It's the speed of light. So one reason that you can't go faster than the speed of light is that if you go up to the speed of light, from the point of view of the rest of the universe, your length would have shrunk all the way to nothing, and you can't shrink any more than that, so you can't go any faster than that. Because if you went faster than that, you'd have to shrink more, and it's impossible to shrink more than totally flat, right? And it's the same thing with time dilation. If something keeps going past you faster and faster and faster, its time will slow down more and more and more. But if you slow down time enough, like if a train went past you fast enough, its time could slow all the way down to stopped. And I don't mean the train is stopped, because the train will still move by, but time inside of the train will have stopped. If you could see the people in there, they would all freeze. Well, guess how fast they're going when time has slowed down to a stop in that train? Guess how fast they're going? Light speed again, yes. Light speed again. So essentially, the two main reasons you can't go faster than the speed of light is that if something went past you at light speed, their length has shrunk all the way to nothing, and that's the most it can shrink, and their time has slowed all the way down to stopped. So that can't slow down, time can't slow down any more than that either. So a particle of light that flies by has no length and is frozen in time. It's still moving, but it does not experience time from our point of view. It's very, very strange.